In this video lecture, we have to concentrate on Cauchy's integral formula. If f of z is analytic within and on the surface of a closed curve C, and if Z0 is a point within C, then the value of f of Z0 equal to 1 divided by 2 pi I integral f of z divided by z minus z0 into dz. This is our Cauchy's integral formula. To understand this, consider a closed curve C. F of z is analytic within and on the surface of a closed curve C. Consider a point Z0, say this is Z0. Which is present within C. Then the value of f of Z0 equal to 1 divided by 2 pi I integral f of z divided by z minus z0 into dz. Now we have to prove this. Even though the function f of z is analytic within and on the surface of the closed curve C, the value of f of z divided by z minus z0 is not analytic at the point z0. Even though f of z is analytic, the value of pi of z, which is equal to this, or pi of z. Assume that this is our pi of z. Pi of z equal to f of z divided by z minus z0 is not analytic at the point Z0. Now, Cauchy's integral theorem is not applicable at Z0. This is not formula. We are talking about Cauchy's integral theorem. Integral theorem means integral pi of z dz equal to 0. That is our integral theorem. The function f of z is analytic within and on the surface of the contour C or closed curve C, but consider a point Z0. At this point Z0, the value of f of z divided by z minus z0 is not analytic. Therefore, the function pi of z equal to f of z divided by z minus z0 is not satisfying the Cauchy's integral theorem, which means that pi of z is at inside integral not equal to 0. Now construct another circle of radius r0 by keeping z0 as center. See this. Construct a circle of radius r by keeping z0 as center and named it as C0. Now the newly developed circle is C0. See here, the function pi of z equal to f of z divided by z minus z0 is not analytic at the point z0, which means that it doesn't satisfy the Cauchy's integral theorem. Now, keeping z0 as center and radius r be the radius, construct another circle that is specified as C0. At present, the function pi of z is analytic in between C and C0. At present, the function pi of z is analytic between C and C0. Now we have to make a cross cut between C and C0. Keeping cross-cut connection between C and C0 generate a new closed surface C dash. See here. Now, keeping cross-cut connection, we are making the cross-cut connection between C and C0, and then we are connecting them. Keeping cross-cut connection between C and C0. If I connect these two, we are getting a new closed surface C dash. Say this is our C dash. This keeping cross-cut connection between C and C0 generate a closed surface C dash. Now the function phi of z is analytic and satisfying Cauchy's integral theorem around a closed surface C dash. Now you have to write the value of phi of z. See here. The value of phi of z phi of z into dz equal to 0. Here we have to use C dash. This is region. Phi of z dz equal to 0 is our Cauchy's integral theorem. Therefore, the function phi of z is analytic. Actually, phi of z is our f of z divided by z minus z0 into dz. Phi of z into dz equal to 0 C dash. This is the meaning for phi of z dz. But from this diagram, C dash equal to C minus C naught. C dash equal to C minus C naught. Therefore, the above integral C dash integral f of z divided by z minus z0 into dz, which is equal to, separate this into two integrals. C f of z divided by z minus z0 into dz minus here C naught. F of z dz divided by z minus z0 entire equal to 0. You have to understand this concept carefully. Phi of z dz equal to 0 in the region C dash. Phi of z is f of z divided by z minus z0. So f of z divided by z minus z0 into dz equal to 0. Actually, C dash is equal to C minus C naught. So this integral is separated into two parts, in terms of C and in terms of C naught. Entire equal to 0. Now we may modify this relation into two individual portions. See here, these two equal to 0. Therefore, f of z divided by z minus z0 into dz C equal to f of z dz divided by z minus z0 C naught. From this relation, we can write integral f of z divided by z minus z0 into dz here C equal to, because these two integrals are equal to 0. Therefore, f of z divided by z minus z0 into dz equal to integral f of z divided by z minus z0 into dz. Here we have to put C naught. Now you have to proceed further. Here you may write f of z equal to f of z0 then plus f of z minus f of z0. See, this f of z is expressed in terms of f of z0 plus f of z minus f of z0. If you add these terms, we can get only f of z. F of z0 minus f of z0, 0. F of z equal to f of z. Now the above integral is modified as integral c f of z divided by z minus z0 into dz, which is equal to f of z0 divided by z minus z0 into dz. This is one part, and the other part is plus integral f of z minus f of z0 divided by z minus z0. Here c0, here also you have to put c0. Now you should concentrate the value of z minus z0. Z minus z0 equal to r into e power I theta. This is the value of z minus z0. Then z equal to z0 plus r into e power I theta. Then dz equal to r e power I theta I into d theta. Now consider the first integral. Here the left hand side is f of z divided by z minus z0 into dz. Here you have to put c. Take this f of z0 outside. Integral dz. The value of dz is IR e power I theta into dt divided by z minus z0 r into e power I theta plus integral C0 f of z, that means f of z0 plus r into e power I theta minus f of z0, here you have dz, whole divided by z minus z0 r into e power I theta. Then the value of dz is IR e power I theta d theta. Now you have to modify this further. Here the left hand side is C f of z divided by z minus z0 into dz, which is equal to f of z0 integral. So here r e power I theta, cancelled out. Then I into d theta. This is the remaining term here. In this case, we may cancel r e power I theta, r e power I theta. Then the value of f of z0 plus r into e power I theta minus f of z0. We can get f of r into e power I theta multiplied by I into d theta. See, this is plus integral C naught f of r into e power I theta, because f of z0 plus r into e power I theta, this is minus f of z0. Therefore, f of r into e power I theta, r into e power I theta, r into e power I theta. So the remaining term is I into d theta. Then this is equal to f of z0. If you use our integral d theta equal to theta, if you apply the limit, upper limit is 2 pi, lower limit is 0. So the answer is here 2 pi I. This I is present as such. Integral of d theta is theta. If you apply the limit, 2 pi. So 2 pi into I. Here, if r approaches 0, this integral value is 0. So you won't consider this integral. This value is 0. Here the left hand side is f of z dz divided by z minus z0 c. From this we can write f of z0 f of z0 equal to 1 divided by 2 pi I integral f of z divided by z minus z0 into dz. These are Cauchy's integral formula.